Hi everyone again. Today we are going to understand the various terms which we will encounter while solving the MCQs for waves and sound chapter. So there are five terms that we need to understand. First is what do we mean by resonant frequency? Second is unison. Third is octave. Fourth is harmonics. And the fifth one is overtones. So let's understand them one by one. First of all, what do we mean by resonant frequency? So, to understand this term resonant frequency, we will have to understand what is the meaning of the word resonance. For that, you can watch my video on resonance. So, here basically it means while solving MCQs, resonant frequency means same frequency, or you can say equal frequency. And the word unison is nothing but a synonym of the same word resonant frequency. So whenever they say that, the example they will use is there is a wire which is in unison with a tuning fork, or if they say there is a wire resonant with a tuning fork. So if this word is used, unison, resonant, basically what does it mean? Both of them mean what? Same frequency, right? So that's the meaning, right? Resonant and unison means same frequency. And once again, to understand this word resonance, we need to watch the video on resonance. It's a different topic, right? Okay, now what does this word octave mean? They will say that there is a set of tuning forks, there is a set of 20 tuning forks, and the frequency of the last tuning fork is an octave of the first, right? So whenever they use this word octave, most often people feel the word here octa will refer to the number 8, but actually that is not the case here. Octave basically means double frequency, right? So if the last tuning fork is an octave of the first, that means the last tuning fork is 2 times the frequency of the first tuning fork. It's double of the given frequency. That is what is the word octave meaning here. Then you may ask, then why is this word octave used? Why a word is used which refers to the number 8? It is because in music, on a keyboard, every eighth key, right? If you see a keyboard with white and black keys, right? So on a keyboard, every eighth key is of double frequency of the first one, right? That is why this word octave is used in the MCQs, and this is one of the most common mistakes found. So please keep in mind, octave basically means double frequency. Okay, then these two terms are more interesting. What do we mean by harmonics, and what do we mean by overtone? So first let's talk about harmonics. The word harmonics is very simple. It basically means multiples of the fundamental frequency n. So what do we mean by fundamental frequency? Fundamental frequency is the lowest frequency with which a given string or a pipe or any kind of instrument, right, gives us a sound. The lowest frequency of the sound is called as the fundamental frequency. So the first number is n, the fundamental, right? This one here is the fundamental. So this is our fundamental frequency. Now, what do we mean by this word harmonics? Harmonics is very simple. All it means is multiples, right? All of these and more, that is the meaning of this word harmonics. Harmonics basically means multiples of the fundamental. The first one is the fundamental, this is the second harmonic, third harmonic, fourth harmonic, fifth harmonic, and so on. Okay, so it's very simple, this word harmonic. And what do we mean by overtones? Now, to understand this word overtone, we need to also keep in mind what happens in case of a vibrating string as well as a closed or a open pipe, right? So in the case of a string, what happens in the case of a string? If the fundamental frequency is n, then the higher modes of vibration of the string will have frequencies 2n, 3n, so 4n and so on. So again, all the harmonics are present here in the case of a string. For more details as to how we get these numbers, why n, 2n, 3n and 4n and so on, why the harmonics, all the harmonics are present in the overtones, you can see my video on modes of vibration of a string, where we discuss everything about a vibrating string. Okay. And if you talk about an open pipe, it's the same. Open pipe, if I call the fundamental frequency as say NO, O stands for open pipe, then what are the higher modes here, or the frequencies above the fundamental, are again you can say the same, very similar to the string. That means after NO we have 2NO, 3NO, 4NO, 5NO and so on. So basically again all the harmonics are present here in the case of a open pipe as well as in the case of a string. But in the case of a closed pipe, something else happens. If I call the fundamental frequency as say NC, and the letter C here means for closed, right? NC, C for closed, then the next mode of vibration. So again, what do we mean by next mode? Please see the video related to pipes. So the next mode of vibration here is not 2n. The second harmonic is missing. It contains the higher modes, they contain only the odd harmonics, 7 and C and so on, right? 1, 3, 5, 7, 9 and so on. Only the odd harmonics are present. So now what does this word overtone mean? So here the word overtone basically refers to everything after the fundamental. Over, tone. Tone again refers to, right, the word tone, a synonym for that is note or frequency. Right? Note, tone and frequency, again these are commonly used words in the MCQs. They mean the same thing. They all refer to frequency. So when I say overtone, what am I talking about? I'm talking about over frequency. Over means the one over the fundamental. So the first one over the fundamental is called as the first overtone, which in the case of a string and open pipe would be the second harmonic, that is 2n. Either 2n you can say for the string or 2NO for the open pipe, right? So to mark it very clearly, this n is my fundamental. This 2n here is my first overtone, in short I'll just call it as OT. 3n here is called as the second overtone. 4n is my third overtone, and so on. And same thing for the open pipe as well. NO is the fundamental, 2NO is the first overtone, 3NO is the second overtone, and so on. So that's fine, right? But in the case of a closed pipe, right, if NC is my fundamental, then what do I call this? Is this my third overtone because it is 3NC? No. This is the first frequency over the fundamental. After the fundamental, the first frequency that is available to us is 3NC. So although this is the third harmonic, but still it is the first overtone, and this one is the second overtone, and so on, right? The third overtone, and so on. So that's what we have to understand here. Overtone means the frequencies after the fundamental, over the fundamental frequency. And we can now generalize that for a string and an open pipe, all the harmonics are present in the overtones, whereas for a closed pipe, only the third, fifth, seventh, that means only the odd harmonics are present in the overtones. Okay, so based on this, now we can even come up with a formula. So the formula we can write for the case of a string as well as for a open pipe, because all the harmonics are present, I can just say for both of them, I can say NP is nothing but P plus 1 times N. So here the letter P will determine the overtone. So let's say, for example, what is N1? So let's call N1 as the first overtone, N value 1. So N1 is equal to 1 plus 1, 2N. Is that true? Let's check. Yes, the first overtone is the second harmonic. Or say, let's talk about the third overtone. So if I put 3 here, then 3 plus 1, 4N. So is the third overtone the fourth harmonic? Yes, it is, right, for the string as well as the open pipe. And for my closed pipe, what can be written is NP. Now since we want only the odd harmonics to be present, right, we can't write P plus 1. So to get a odd number, we will write 2P plus 1 times the fundamental N, and we can check it again. Let's talk about the first overtone. So if I want N1, which is the first overtone, let's put P equal to 1. So I'll get 2 ones are 2 plus 1, 3N. So is the first overtone the third harmonic? Yes, right. So if you want, you can put a suffix C here. Here, N, instead of N, you can either keep it as N, or you can say NS for string, or you can say NO for open pipe. It doesn't matter, whichever, right? Anyways, all the harmonics are present for both of them. And for a closed pipe, if you want, you can say 2P plus 1 NC. Let's check the third overtone. 3 2 is 6 plus 1, 7 NC. Is the third overtone the seventh harmonic, or 7 times the fundamental? Yes, it is, right? So this is our understanding of all the terms. Again, resonant frequency or unison basically refers to, right, the same frequency, right, equal frequency, you can say. Octave means double. Harmonics basically means all the multiples of the fundamental. Overtone means the frequencies which are over, right, the frequencies which are over the fundamental, right. So in the case of open pipe and string, all the harmonics are present, even and odd, all harmonics are present, whereas in the case of a closed pipe, only the odd harmonics are present. So to generalize, we can write the formula NP is equal to P plus 1 N, and for a closed pipe we can say NP is equal to 2P plus 1 NC.